My room is kind of small, especially for the amount of stuff I do in here. It's a slinky. Did not want to be in there. I'm freeing it from its bondage. How much feet is this? Wow, I have a lot of wire. Ow! Okay, I think I need 23 feet of wire. Yeah, custom DX Ray Searcher. Let's see. This is the wire I bought to make a kiln, but I'm going to use it to make a Hotwire foam cutter for now. I'm going to use 23 feet. Oh no, I hope I didn't tangle it. I'm using 120 volts direct AC, so I'm not using a battery. Okay, how am I going to do this? Because you need the correct length to get the correct amps and the correct resistance. I need 23 feet in order to give me 9.23 ohms of resistance at 120 volts and 13 amps. Those are all my calculations with Ohm's law. Okay, so 6. Actually, I should probably measure it more accurately than that. Nah, never mind. Not gonna. Wait, should I? No, wait. Kind of matters. How do you measure wire, though? That's 5 feet. I'm going to mark it in 5-foot increments. How many watts should Hotwire foam cutter have? I'm not going to use a transformer though. $600. Oh man, I'm at double that. So my Hotwire foam cutter is going to be super hot. It's going to be better than everybody else's. It's going to incinerate the foam. I think that's a good thing. The hotter the better, right? You can't be too hot, right? too hot to ruin the wire? No, it wouldn't ruin the wire because this wire was recommended for making a kiln, which I wanted to make to do metalworking, and the kiln needs to be minimum 1500 to 1800 watts, and this wire is designed and tested at those temperatures, at those wattage amounts, to be used for a kiln. So I'm using the wire I bought for a kiln as a hot wire cutter wire, so I'm positive that it would not be too hot for this wire or too many watts for this wire. Although I don't know if I'm running too many amps through it though, but 13 amps seems reasonable to me. Yeah, it's going to be fine in terms of the amps as well, because that's how many amps you need to get that many watts. So it all is good. It's really good. I'm trying to design what's going to hold this wire taut in a vertical position like this. Like in place of my arms, it needs to be held by something mechanical. And it needs to be a U-shaped enclosure pulling it taut. And right now I'm thinking of using copper pipe. Like a huge version of this, with the cutting blade being my hot wire cutter, and except instead of this U being like this, it's going to be, you know, like this. And yeah, and ideally I'd want wherever it connects to be something that would not melt or start on fire. And also I don't want this to be electrified, so I feel like the attachment joints would need to be somehow separated from this wire so that this isn't all live. I guess it could be live though, I don't know. How do people normally do it? What if I just see what it looks like? I'm just gonna look at like what they look like. I don't need to reinvent the wheel. The handle will act as a heatsink. Okay, that's good to know, but I'm thinking like, how close will this wire be? Yeah, it'll probably be fine. Let's just wing it. Let's just wing it. We'll just wing it, guys. Why not? Okay, I'm going to be using AC power. I'm going to be connecting this directly to a 120 volt outlet. I have 23 feet of nichrome wire, which is 9.23 ohms of resistance, and it's going to produce at 120 volts 13 amps and 1560 watts of power. All that math is using Ohm's law. I'm not going to die. I just got to make sure I don't touch this live wire, because it's going to have live AC running through it. How will I die? There won't be fireworks. 15 amps can kill. Actually, that's not necessarily true. I read up a lot. 15 amps at 120 volts is a standard household outlet. I'm going to be going with 13 amps so it doesn't trip the breaker. And 15 amps, people get electrocuted by standard household outlets all the time. They don't kill you. The 220 volt ones will, but this is only 120 volt. So it's not enough to kill. It'll zap you, but it will not kill you. Maybe unless we have a pacemaker or something. Where would I connect this? Maybe like, okay. Like, I need to know where to put the res. Yeah, it does extend outside my room. It will be live wire running 120 volts, 13 amps. So hopefully nobody will accidentally bump into it. The other end to your junk? Oh, man. Wait, I know. I'll put it around my door handle. Is this getting better? Is this getting safe? This is safe, right? Like, I don't know what to do with all this extra wire. You need 23 feet of wire. Because I have all this is going to be live electrical wire, and I can't just like put it on my bed and turn it on. It'd melt through my bed, like it'd start a fire. So I'm thinking like I need to dissipate a lot of heat, so I need to spread it across the room so that this heat is like, you know, floating up across the whole room. My whole room becomes a big heat sink. Actually, I could probably put it around this lamp. This is aluminum. I don't have that much wire left. Oh, this is plastic though. I'm going to attach it to power once I feel that everything's safe and up to code. I have to get it up to code first. Guys, do you think OSHA would approve right now? Oh, man. Oh, my goodness. We gotta ask OSHA what they think. Oh! If you want to know why I don't have employees, it's because I don't always work up to code, I think. Like, I'm pretty close to being up to code, but I don't know. Like, sometimes I fall short by a little bit. Okay, TXT, the reason a paperclip sparks is because the amount of resistance in a paperclip is only that little bit of metal, and so you're getting too many amps. Because it's just a very short amount of metal, the amount of resistance that offers for the electric is negligible. But I'm using 23 feet of metal, which offers so much resistance that you're able to regulate the amount of amps running through it. And by reducing the amount of amps, you make it the electric flow at a acceptable rate of speed so that it doesn't get so hot it creates sparks. It's not enough amperage. So the key is to get the correct resistance, and the correct resistance to get the proper amount of amps, which is 13 amps, which will not blow my breaker, is 9.23 ohms or 23 feet of nichrome wire. Also, somebody asked what kind of nichrome this is. This is 18 AWG. 18 gauge nichrome, which has 0.42 ohms of resistance per foot, and I'm using 23 feet. My door handle is metal, and I don't see how that would melt or be a problem. Also, the door is made of like fiberglass composite or something. I don't think that will melt by its proximity. And the closest plastic on here is right here. That's kind of close for my comfort. I'd prefer it to be like right here. I'm going to try to get it to stay right here. So we got wire here. It's running all the way across my room to my door handle. That will all be live wire. We got it running from my desk handle to these weights on the floor. It's wrapped around this weight. And so we've got a nice vertical wire right here. And that will be what I use as my cutting blade. Nothing else will be on the circuit, armchair. I'm running an extension cord directly from my living room or the basement, and nothing else is connected. So it's going to run 13 watts, which should be below the 15 watt breaker. I mean, it's going to run 13 amps, which will be below the 15 amp breaker. Unless it's a 20 amp breaker. Some breakers are 20 amps. I'm not sure which it is on this one, but it should be below that as long as nothing else is on that circuit. And I'm just going to connect it directly to that circuit. How does it work? I'm going to connect an electric line to here and to here, and then all of this wire will be live. This will be live. It's going to turn orange. It's going to be red hot, and I'll be able to then use this vertical wire to cut foam. I got some aluminum stuff. Might be able to use it somehow. Okay. Boom! Wow, that's pretty taut. Right now, we got the wire running from here, and there's an end piece. We got it running there, all the way to my door handle, and then wrapping around the door handle, then coming all the way back to here, and then going down to the floor, and then wrapping around that once, and then coming up right here. So this is my vertical And it's pretty taut. Like, that's taut. But what I don't like is that this is all like right by me. Like, it's literally right here. And this is going to be hot wire, like maybe, let's say like 700 or 800 degrees hot. It's going to turn orange even. And I don't like it being like right here. Like all I have to do is bump it with my arm. So I'm thinking like maybe I want to like have it go out that way, like wrap around up there, like from the lamp to there, or something like that. There we go. What if I do this door handle? The reason why I don't get the Darwin Award is because of all this fiddling I do. I get things right. I check and I double check. You know, it might be sketchy, my techniques, but because I'm thorough and careful and think it through twice, I don't have the big accidents. There. There. Boom. Next thing I need is a guide along the bottom to keep it flat. I need like a table. It's not level. That's pretty level. I'm going to be cutting it like here and then a circle in the middle, which I can draw on the top with marker first and then just slide it. This thing needs to be ridiculously plumb. The way to get something plumb is you tie a string I'm going to make my own plumb line out of this thread. Okay, it needs to go that way about ½ an inch. Okay. This thing keeps twisting too much. I need... Ooh, maybe I'll use a key. Or scissors or something. I feel like a key would work. key is appropriate considering Benjamin Franklin, or was it Benjamin Franklin, invented electricity from tying a key to a string with a kite? Wow, that is really plumb now. I have to select a copper wire now. So let me go find that. How perfect. So we got here now 2 copper wires and a plug. I gotta connect one end of the copper to here and one end to there, and we're golden. There's our electrical connection. You can see the wire goes down to my closet. Door handle, 23 feet, comes down, wraps around this aluminum thing. I got a weight behind it as a heat sink so it doesn't burn the carpet. Wraps around once and then wraps under and around and then comes up and wraps around that a couple times. So the wire is coming down and under, through here, out the other side of this thing, and then it comes up right here, and then I just wrap it around and then stubs here. And I gotta connect this to here now. Okay, so I got it wired now to the top and bottom, and I got a plug. I can plug this in now. As you realize, if I plug this in, it's live. I gotta do one last check. Holy crap. If I plug this in, we are live. Oh! Just found a flaw. Gotta fix it. This has to be like here. There. Guys, this might be my last stream, so I just want you to know it was enjoyable knowing you all, and you're all in my will. Okay, this is one of those YOLO moments in life. I feel like I'm about to jump off a cliff or something. Take some deep breath. Okay. Okay. We got this. We're doing it! Oh shoot! No! Okay, I'm doing it! Holy crap! Oh my gosh, look!
Holy crap! Okay, this cord is in the way. Okay, better. Boom! Guys, I'm alive! I'm alive! What? What? Whew. Let's see if it can work again. Okay. Here we go again, round 2. Guys, it actually does spark, by the way. You'll see it.